won't work as well. So if you scan a flat table, for example, then the HD Prime Pack won't work as well. You need the features. And last but not least, the food station. The food station is also a new add-on. We also had a previous webinar about it. You can only buy for the 2X Plus scanner, and you can capture like the whole food pretty fast and even get a report automatically afterwards. What are the benefits of our IronScan Pro 2X Plus? First of all, it's a hybrid scanner, so you can scan handheld and in the fixed scan mode. We have free software updates for our scanning software. We have a unique software design. You will see it later in our webinar, so it's pretty easy to go through the software. A pretty unique dark design, plug and play. So if you get the scanner, just plug it in. We have a help mode in our software which guides you through the software. We have a really high accuracy. We have unlimited seats for our Xscan software, so you can install it on as many computers as you want. And you can just need to plug in the scanner USB 3.0, and then you can start scanning. And another benefit, it's flexible, and you can flexible upgrade it with the add-ons, as I showed you before. And you can always do it anytime. To shortly introduce you the Veriserve software, Shining and 3D, we cooperate together with Veriserve for the inspection part and for the reverse engineering part, which you will see today. So what are the benefits of Veriserve? First of all, it's a pretty heavy software, so you can do a lot of stuff with it. You can like attach your laser tracker on it. You can attach the optical trackers. You can use a scan arm for Veriserve, a scanner itself, a laser projector, or a normal CMM machine. So you see that Veriserve has a wide range of usage itself. So you can use it for different kind of technologies. Today we will only look at the 3D scanner side. To get through it, it has like its own circle over here. So we have the analysis part, which is the inspection part we showed you some weeks ago. We have the reverse engineering part, which we will show you today. The automated one with the CMM machine, a normal CAD design itself, and for sure the measurement function itself. I will first of all show you the EXScan Pro software, and on the see which device is connected. I'm using the IronScan Pro 2X Plus. On the right side, the calibration information, when you did the calibration the last time, and in the middle of the screen you can see the different scan modes. The first scan mode is the fixed scan mode, which we use today. The next one is the handheld HD scan mode, and the last one is the handheld rapid scan mode. The handheld HD scan mode is only for marker scanning, and the rapid scan mode is for without markers, to scan, for example, a human person or an object with a lot of features on it. Up there, you have the community button, so you can share your scans, or you can give feedback to our software. The next one is the settings itself. You can choose the language. You can get the about information, and also the user feedback. And we have also the factory defaults. You have a helper mode over here if you start for the first time, and we have our team viewer as well. So if you start this, you will automatically get a team viewer open up, and our support colleagues can connect to your computer and check out what the problem is. So let's start with the first scan. Let's create the first workspace over here. So we scan this part over here. It's a 3D printed FDM part, white. Let me adjust the turntable a little bit, and then we can see the first really important thing. The cross should be, the red cross should be on the projector cross, and also the brightness is really important. HDR mode means if you want to get black and white objects, the scanner will do both shots, like really dark, really like bright and really low. We have the different alignment modes for features, if you have enough features on the object, or if you stick markers on the object, but we will go for the turntable coded targets. 8 steps is fine, and what we'll do right now, as I said before, we will have 8 turntable steps. So he will like turn around 8 times, or until he finished the whole object itself. It's our first shot we will do, or our first 8 shots we will do. The software also aligns those 8 shots automatically together. So there is not really more we need to do right now. We just need to wait until the whole process is finished. The pretty nice thing is we can like get a coffee or something else, or we can work on something else. During the moment, the scanner is capturing the object over here. Yes, it's almost finished. It turns one more time, and there we go. So it's finished over here. We can look around. I can see already that we have scanned a little bit of the blue tag over here, and we can just go on it and delete it out pretty fast. It looks pretty good. We accept it. And now I'm gonna turn the object on the other side. Yes, let's put it like that. Adjust the turntable a little bit, and then we press start again, check the adjustments, and go. It's really important to keep in mind that if you scan a white object, please take care that the brightness is not too bright, or also the room itself. Light can really affect the scan itself. So if you have a really bright light in your factory or in your office, please check that. And if the scanner doesn't capture anything, it's probably the light itself or the distance. As I said, the distance you can see over here with the red cross and the cross on the object itself. If those are perfectly fitting together, you have the perfect distance. You can also see now we are adding a group 2. It's the second scan group. It's pretty cool because afterwards we can also align each scan, the second scan group. We can just accept it, and the software will automatically align those two scanning data together. So I would say it looks pretty good already. We've just missed a little bit of the part. Let me turn it around. And I could do just like press start again, but that would take a lot of time, and I'm just missing the edge over here. So I will disable the turntable and just do one shot over here. That's what we will do right now. Just create one shot. Let me delete all the markers you could see because they are white as well for the one shot. No, I don't want to delete the whole object. Yes, I want to delete just the markers. Accept it. And there we go. We can see now there's a misalignment because there was nothing much to align, but it's not a big deal. We have over here the alignment function, so we can drag and drop the group 1 first of all, and then our just the single shot itself, and then we set like 3 common points. So we choose it on both sides, 3 common points. That's pretty fast, pretty easy, and that's how the software now, or we will help the software to align the data. So it's perfect over here. If you're finished, we can click on confirm, and over here we have our objects. Maybe there's missing, it's not a big deal, we can adjust it later. We can also adjust the name of the projects or the groups itself, and always change that as well. We can also hide scans. If we hide scans, we will not mesh them, so that's really important as well. So I hide now this scan, as you can see. Yeah, there we go. If you're fine, we just go on watertight right now. And watertight means the software will automatically close all the open holes. We still have, if we wouldn't do that, I could also do it later in the post-process function. So we can close holes manually. But in this webinar, we won't do that detailed to go through the whole software itself. But if you have more questions, just check out our old webinars, and we will show you how to close holes, for example, in our software, and how to do all the manual adjustments you want to do. This webinar will focus on the VeriSurf part as well, like the reverse engineering part of this thing, of this object over here. So let us calculate the mesh. Meshing means the software will go from the point cloud to an STL file. So as we could see it before that. Before we worked with just the points in the coordinate system, a lot of millions of points, and right now we are getting from the points to triangles, and that will generate the STL file. Really important as well, if we scan in the fixed scan modes, we will have the highest resolution and the highest details itself. So currently the accuracy itself, so it's a pretty high resolution and a pretty high accuracy, sorry, for I would say 99% of the whole reverse engineering jobs you need to do, and you need to stay within. So I don't, as you see over here, that's the meshing process. So now we have 98%, almost finished, and then we can, yes, there we go. So now we're in the post process function. The first thing we can do over here is we can, for example, smooth or sharpen the object. That's what we can do. That's what I want to show you right now. So let's check it out, how the mesh looks like. Do you remember we had some open holes, but we don't see them anymore? Pretty nice details. We see the FDM printing, the support over here. It looks, I would say, pretty nice. Let's say we want to smooth the whole object a little bit more. Because I don't want to see the printing that much, and even if I create the features afterwards, the deviation will be a little bit higher for sure. So we will smooth that a little bit. That will take a second, and there we go. If you're not fine with that, we could just like re-smooth it again, but let's say we are fine over here. And the next thing we can do the simplification. So currently the file is around 200 megabytes. To be honest, that's a lot, and I want to like increase the speed afterwards in Verisurf itself. So to around about 100 megabytes. Okay, there we go. Almost done, and you will see the result doesn't really affect. So we tried it a lot, or I tried it a lot, so I can say you can always reduce it by 50%, and that's always fine. So now we're done over here. That looks pretty good. Let me show you a little bit to scan, and then we will jump into the measurement function. So what the functions over here is we can first of all create features. First of all, the first thing we will create is a point itself. Let's get the point over here. No, there. I think down. I want to align it over there. So perfect. Let me get a line. Yeah. Select by 2 points. Create, and we have the line. And let us create one more plane over here. We will pick 3 coin points again and create a plane. That looks pretty decent, and we can go on the movement function. So what I want to do is now I want to move the whole thing to the coordinate system. So afterwards in Verisurf, it's easier to do the reverse engineering job. It's done over here, and it looks already perfect, aligned in my coordinate system. So when I've done that, I can also go to the measurement function and measure, for example, from to this point over here and get like a pretty short measurement, pretty short information about it. I could also do the surface area itself, so I can choose it, calculate, and this would just be calculated for the upper part itself, or I can create a volume, and that will only work when I have a water type model for sure. Otherwise, the volume you couldn't calculate. All those information, as I told you, you're getting automatically out of our scanning software. Let's go into the next step and just save the file over here. Sorry, I need to choose a folder for it. Part 1. Folder, sorry. There we go. And now I can save it, and you can see the dimensions again. You could also like scale them, but that's it. So that's the whole thing about the software. Let's jump into the reverse engineering part. Thanks a lot.
Verisurf software helps manufacturers improve quality and increase efficiency while saving time and money. Verisurf works closely with customers to automate first article and production inspection, scanning and reverse engineering, tool building, and assembly guidance processes. The software lets users interact with parts both physically and digitally in real time, capturing measurement data, comparing features to nominal GD&T specifications, generating reports, and creating intelligent geometry.
One of the things that makes our software unique is our commitment to model-based definition, commonly referred to as MBD. With MBD, the CAD model is the nominal definition to which all parts are measured and inspection is included in the CAD model. This maintains digital consistency from design to manufacturing to inspection and quality reporting. We pioneered MBD for model-based inspection, displaying real-time deviation on the PC platform, and it remains the core of our software today.
Verisurf software is built on a CAD platform with true intelligent 3D modeling, open platform architecture, and Verisurf device interface, making it compatible with virtually all CAD software and measurement hardware. With its universal compatibility, Verisurf is the only measurement software you need.
In this video, we'll be looking at reverse engineering. So we have a scan part, a mesh file, STL. So first thing, let's create some geometry. Edit mesh, area select. We have different selection tools, all the typical area select, single select, neighborhood, round disk, square disk, window. We'll stick with area select. We have different things we can do with the interaction. With the selection, we can smooth it, sharpen, refine, filter, delete it, copy it, cut it, and then we can fit features. So here now I'm going to fit a plane. We're in area select. Change the angle of incidence up. Okay. We'll just back it off a little bit. Take it away from this edge down here. Now I want to fit some circles in these holes. So it'll fit. One there. One there. Clear that. Change this back down to 3. One there. Back this up a bit. Fit. Okay. Then we can see the circles on the plane. Let's fit a couple more planes. Choose the relevant feature, plane. Select. We can see it's gone down the side, so we'll reduce the angle down a bit. Okay, that's good. We'll fit. Then we'll fit the last plane here in this little pocket. Change it down. Let's see what 3 does. Okay, that looks good. We'll fit a plane there. Okay, so now I've got some geometry to work with. First of all, I want to look at the circles. So we can see the different diameters. Okay, so first of all, I'm going to reduce the noise in each of these. Double click, reduce noise. So you can see it takes it down quite a bit. So it gets a good fit. One more. Okay. So now I want to select them, right mouse, set values, and we'll apply some design intent. So we'll choose diameter, we'll make them all 16mm. Okay, so now we can do an alignment on this. Let's turn on the Nomen so we can see. Let's go to transform, measure, feature align. Okay, plane 1, I'm going to choose the Z-axis direction for this plane here. I want to choose the y-axis to go from circle 2 through circle 3. Okay, and I want the origin to be for the xy plane, circle 1, and to take the z value from plane 1. Let's turn this back off. Okay, so now let's start and create some wireframe geometry to work with. So I'll take the circles, right mouse, export to CAD. Behind them, where you can see, there's the CAD geometry. We don't need the center points, so we can select all CAD points and delete. So now we'll select the circles, right mouse, we'll put it on a different level so we can turn it on and off. So now we're going to give it a number, we'll give it a name. We'll call it wireframe. Okay. Let's go back to the scan. So now let's start and create some slices to work with. Okay, so let's go into a nice front view. We go reverse. That was on here. Slice mesh. We can slice along the X, Y or Z. Obviously our Z goes up here. So I want to create a slice not right at the bottom because there's a radius. So I'll take a slice here and I'll take a slice round about where it is now. Okay. So with that slice, it's just above the radius. So to move it, you can drag it, or you can actually click in the graphics window and you can drag down. So I'll take it to about here. What I'm going to do is save a cloud, and I'm going to save it with points every millimeter. So I'll go slice. Now we'll create another one. Drag this down. Again, there's a radius on the bottom, so I'll come up a little bit. Maybe there. And slice. We close there. Let's look at this. Let's look at a top view. We'll turn off. And there you can see the two clouds. If I turn them off, there's the one that was on the 0. So what we'll do is we'll send these to CAD. So export to CAD. Okay. So now what we can do, we can make a spline through these. So we use the wireframe, spline, automatic. Okay, select the first point, let's zoom in a bit. Select the second point and the last point. Okay. Now we can go back to our quick mask selection. We don't need the points anymore. Delete. So there's the spline. We still need to project it, but we have the spline. Look at this one here. Export to CAD. Do the same again. We'll create a wireframe. Spline automatic. First point, last point. There we go. Same situation. Quick mask. Select the points, delete. Okay, so there is the two splines. There's the mesh, and that's where they are. So we need to project the first spline to there, and this one at the bottom to the bottom face. So we need to find out the distance between this plane and this plane, so we know where to project this to. Okay, so plane, if we select plane 1 and control, oops, plane 2, we can see it's between 18.3, 18.25. Let's call it 18.25. Okay, we know where to project that to. So let's go on the top view. This one first, the bottom one. So we'll go transform, we want to project. We select it, end selection. We want to move it, not copy it. And a depth, it's minus 18.25. Enter. The next operation is this one. Click, end selection, and this is 0. It's on the 0 plane. So now we can click remove colors. look at the mesh. There we go. So there's the slice directly on this plane, and there's the other slice directly on the bottom plane. Okay. So what else do we need? We can use this slice to drag and create a solid body. We have this slice that we need to just trim a bit to cut out the pocket here. So we need to create a surface out of this top piece here of the mesh so we can cut the solid body. So let's go into top view. Let's go right mouse, edit mesh, area select. Okay, that's too much there. Let's call it an angle of 3, see what it looks like. Still going down the sides a bit, so we'll reduce it down a bit. Now you can see, it's just left the top surface. So now we can copy this. Okay, so now we have that there. Okay, let's go on the levels. Let's select all this. Right mouse, and make sure it's on the wireframe. Okay, okay. Let's leave this open, turn that off. Turn on the copy. Go into reverse. Go power surface. Okay, so what this does, it puts a surface through the selection. One of the most important things is the point weighting. Okay, if I change this to 1, you can see it's not very nice at all. You want a small point weighting, 0.05. Okay, it takes the shape of the mesh that we cut. What's also very important is to extend the surface so it comes past the outside of the part, because we're going to use this surface to cut the solid body, so it needs to extend past the solid body. So with a 5%, this goes past the outside. Okay, we say okay to that. So let's take this surface and let's put it on a separate level. Select, give it a number, give it a name, let's call it surface. Okay, let's turn it off for now. Okay, we can go back. Let's turn on the wireframe. Okay, now we need to trim this wireframe here. Okay, so we can select this, we can go Alt-E and just leave this wireframe here. The bottom wireframe was projected to the base of the scan, so that's fine. We only want to use a part of this to cut. Okay, so we go to wireframe, break into 2 pieces, select it where we're going to break it. Okay, so now if we break again, select, break here, escape. So now when I select this, I can see the selection, I can click, delete. So now I want to take it past the edge of the part. Okay, if I put this on wireframe, we want to take it past the edge just to make sure we're completely free of the solid model. Okay, so what we can do, let's turn this back off. We're in the top view, just make sure, yes. We want to create a line, so we'll go line endpoint, and we'll do horizontal. Click here, drag it out. Click this one, start to drag it, and then if we click here, it will make the line the same size. Go vertical, click here, click here. Okay. So now we have a spline to cut the solid body as well. So we go Alt-E, just bring back the rest of the selection. Okay. we want to make sure that these splines and this is projected to the 0, just to make sure. Transform, project. We'll select this. We'll select the circles as well. Go end selection to the 0. Enter. We're going to move them. Yes. Okay. So this spline and these circles are directly on the 0 axis. So now we can start and create some solid bodies. Go solids, extrude. Okay. Let's choose this one. Yes. And here we want to make sure that it passes. So you get a slider bar, we need to pass the scan. So here we could type 40, it's going to pass it. Okay. Solid, accept. So now we have a solid body there. It's passed the scan. So now we want to cut this solid body with the surface we had before. Let's turn this off. Let's go top view. Let's turn on the surface. Okay, so now we're going to cut the solid body with this surface. So we go into the solid menu, trim by plane, hit the drop down, trim to surface sheet. So we select the solid body. Now it's asking us to select the surface. Okay, we want to reverse the direction. Okay, that's good. Now we turn the surface off. So now we've got starting to get the essential shape of the solid body. So now we can extrude this one, this, enter. We want to cut the body. Okay. Now we need to find out how deep these holes are to cut. So if we go to the reverse tab, let's turn off the solids. Well, put this on a separate level. Select the solid, select, give it a number, give it a name, solid. Okay, let's turn it off for now. Go back to reverse, turn on the mesh. So we want to know the depth of these holes. We've already got plane 1, so let's go edit mesh, select plane, let's choose one of them. That's too much. Let's go down to 3. Okay, let's fit a plane. So if we look from plane 1 and then control, plane 4, okay, 7.05345. So let's call it 7 millimeters. Okay, we don't need this plane now, we can delete this. Yes. Okay, let's turn back on the solid. Let's go extrude. Select these circles. Tick. And here, 7. And we want to go the opposite direction, down. And cut body. Okay, so now it's starting to take shape. So now we need to, let's go back to reverse, turn the mesh on, go to top view. And we'll slice the mesh again. Go reverse, slice. Okay, it's in the Z axis. We can use the slider bar. And bring it in. And see how it's bringing it in there? See there? Slowly take it back. We want to capture this slice here. We can see it there. That looks good. Again, cloud with points for millimeters spaced. Go slice. Let's close this. Hide the mesh. Okay. There's one. There's the other. We don't need this one. We can delete. That's the one we want. In fact, we can delete these other two. We don't need them anymore. Okay, so this one we export again. Same procedure, export to CAD. Now we can create again the curve. We'll go wireframe, manual spline, automatic. Zoom in a bit, click the first, click the second, click the last. Okay. Again, we don't need the points. Delete. Okay. So now we need to project this to a plane. And we had that plane there, like this. So we can't do anything with a measured entity, we need to make it CAD. So export to CAD. So now we have a CAD plane here. I want to grow it a little bit. Tools, grow plane. Just so it passes, we need to project the plane onto there. Okay, so you can see that the spline is above the plane. So let's go to transform, project, select the wireframe. And here now we tell it to project to a surface. Click, and now you can see it's projected to the plane. Right mouse, clear colors. Okay, so let's take this, right mouse, select, let's put it in the surface layer. Okay. Now if we look here in the solid, okay, let's go wireframe so we can see through. Okay, we'll extrude this now. So go back to solids, extrude, select the curve. Okay, go back to shaded so we can see what we're doing. We want to go the opposite way. Okay, and there's the extrusion. Okay, let's turn off the solid. Let's select everything, make sure it's on the wireframe. Okay, let's turn the wireframe off, solid back on. So there we can see we start to build the shape of this. So now we could put some fillets on. Let's select the face. There. 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 Here. And here. So okay. Let's try 1.5. Okay. So there we have the scan turned into a solid model. Okay, so that was a quick video on reverse engineering from a scanned part.
That's it for the VeriSurf session today. I hope you enjoyed it, and we could show you a little bit the functions of VeriSurf. Also, with me here, there's Dave Armstrong. Dave Armstrong is the sales engineer for VeriSurf in the whole EMEA area. So if you have some specific questions right now, you can ask them, and probably Dave can answer that. So Dave, can you hear us, or can you get your microphone on? No, Dave is... Dave?
Yes, I can hear you.
Ah, perfect. So hi, Dave. Thank you again for the demonstration for the VeriSurf part. Pretty cool, pretty nice features, I would say. And it was pretty quick to do the reverse engineering job. So I have like a question from Tim. Did you see that? The question from Tim with Mastercam and SolidWorks.
Scanner. I don't have experience with SolidWorks. So he wants to take scan data from his scanner and use it in SolidWorks.
Okay. So,
Yeah.
okay, I know, I get the question. So for SolidWorks, it's pretty hard to import scanning data into SolidWorks. That's the reason why we cooperate with Verisurf together and with the reverse engineering softwares, because you need to go from the STL file, which you will get off the scanner, to a like STEP or IGES or a CAD file. So that's what Dave Armstrong showed us today. Like, go from a STL file to a CAD file you can later on import into your SolidWorks. So that's the reason why we made this webinar, how to like go from an STL to a CAD file, which you can import in any CAD software. So I hope that answered your question. There is another question. Verisurf is an add-on for Mastercam, and Mastercam is an add-on for SolidWorks. Yeah, for sure. Okay. Do you have any DLL files for using 3D Space Mouse from 3D Connection in Einscan software? No, we don't have that. Do you have that in your software, Dave? That you can connect to 3D Space Mouse?
That I'm not sure. I'd have to find out and let you know.
Okay, great, perfect.
So I see the next.
Question.
Yeah. I see. So Verisurf is not really an add-on. It's a software in its own right, and it's built on top of the Mastercam platform. Okay, so it's not an add-on. It's a software standalone in its own right, but it's using the Mastercam platform. That's where we get the power of the CAD.
Yes, and I think there's a pretty interesting question from John, Dave. He asked if you also can import scans and measure it inside the software. And I think that's the huge benefit about Verisurf.
Yeah, exactly.
If you can just contact us, get a quote, and you can do both reverse engineering and inspection within Verisurf.
Exactly.
I think in the last webinar, you can find it on YouTube, by the way. You can find it's our FreeScan webinar together with Verisurf. And Dave in this webinar is introducing the analysis function from Verisurf itself and how automated it works. That was a pretty nice webinar as well, just to keep that in mind.
I'm just looking at the last question, Neil, about the automatically import and measure. Yeah, we showed this a little bit on the last webinar, where we can import a mesh. We have a program. It will automatically align, and then we can inspect automatically.
Yes. We did not see, somebody's asking, we did not see the deviation between scan and the reverse model. I think, Dave, in the next webinar, we can show that, I'm pretty sure.
Exactly. In a few weeks, we'll do the freeform surface fitting. We have some very exciting new things to show you, and we'll definitely do some color maps and things like this.
Yeah, I think we can already like preview a little bit, because we will show some unique stuff also for the Einscan. We will show a new update for the Einscan SP, like a software update, a huge one. So you should stay in line for that, which will be really amazing. And there will be also like with the freeform part from Verisurf. So I'm really excited as well to see that in the next weeks. So there's another question, Dave. Scanning data export into Mastercam software, because we already use Mastercam for software. Yeah, maybe Dave, you can explain that Verisurf is not Mastercam itself, it's just based on Mastercam.
Yeah, so it's based on the Mastercam platform. It's where we get the power of the CAD. So Mastercam can import many different types of format. So we can take point clouds in for scan data. We can take STL mesh data in. We can take point clouds, meshes rather, with color. So yeah, we can do all this.
I also see pretty often the question like how much Verisurf costs. So for that question, just contact me and we will figure it out. If you have an Einscan, we have a pretty special offer right now. If you don't have an Einscan and you want to buy an Einscan with Verisurf together, send us a message as well, and you will get a really nice offer as well. I will post after this webinar, you all will get my mail address, so you can contact me without any problems, and you can get the offer for VeriServe. There's another question, Dave. VeriServe is a 100% add-on, so you can, that's from Kai, okay. He just answered it by himself. Hi, my question is why we need reverse engineering software like VeriServe, where you can get dimensions and info on 3D scanner. So the question why you need VeriServe is because Shining 3D just offers we focus ourselves on the 3D scanning part. So to do reverse engineering or to create a CAD software, to create a software like VeriServe, that's not our business. That's not our main business. So our business is to create the scanners, to get the scanning data, the STL, and for sure you can 3D print an STL data, but if you want to reproduce it, or you want to reuse the data, then you need to do the reverse engineering part, which what Dave showed us today. So that's why you need such a software. And also for sure for inspection. If you scan something and you want to do quality control, VeriServe could be your right tool as well. Is there any matching tool to fit scan to scan or scan to solid in VeriServe, Dave?
Yes, there is. Yes, we can compare scan to scan, so mesh to mesh, mesh to CAD. 100% no problem.
Approximately when will the software update for the Pro and Pro Plus come out? I give you one tip. Just if you have already an Einscan, subscribe to or check out our Einscan expert group at Facebook. We always search for beta testers for such softwares. If you're interested in, go on this Facebook group, and you can connect with other users. And approximately about the update, it will be, I think the plan is the end of this next month. So middle of next month, end of next month, you should get an update for the Pro and Pro Plus scanner. Okay. What is new in the Pro and Pro Plus? So all the functions you could see in the 2X scanners, like the alignment to the coordinate system, the measurement, the basic like point-to-point measuring, is available in the new Pro and Pro Plus software updates, which you will get for free for sure from us. Okay, Dave, I think we answered all the questions.
Okay.
Thank you again very, very much for your kind presentation, and thanks for sure everybody for joining today. If you have any question, just contact us, and Dave and we will try to answer all the questions.
Yeah, thank you everyone, and make sure to keep a lookout for the next webinar on freeform surface fitting. You'll like it.
Great. Cool. Thanks again, and stay healthy all. Bye.
Thanks, Niels.